Well, welcome to another edition of Fire and Training. I'm your host, Douglas Cline, and I'm excited about today's show. Joining me is a really good friend, FDIC colleague, fire service training guy that I'm just excited to have on the show. It's Paul Watlington from the Burlington, North Carolina Fire Department. Paul's got an associate's degree working on his bachelor's degree from the Center for Public Safety Excellence. He's a chief training officer. Paul, it's great to have you on the show.
Chief, I appreciate it, man. Thank you. I appreciate you having me. Looking forward to it.
You know what's going to be really cool is we're going to talk about a topic today that most people probably wouldn't dive into, but you and I both recognize just how important this topic really is when it comes to fireground operations, to working together in a collaborative effort. We talk about fire attack and ventilation being a coordinated effort. I've heard you say in your programs about fire attack and pump operations being a coordinated effort as well. And that's what we're going to talk about today is making the pump operator great again. And that's a coined phrase that you used. And honestly, it's true. It's one of the most critical positions that we have on a fireground operation or on any operations when it evolves around water flowing from a fire apparatus, no matter what that type of situation is on emergency response. But, you know, our pump operators, and I'm going to use an analogy here. You can be a pump operator and pull levers. And, you know, you can twist the knobs, you can pull the levers. You can push the little buttons, but is that really being a pump operator? And we all know that is not correct. There's a lot more that goes into it, and we're going to dive into this today. So I'm going to kick it over to you and say, stellar presentation at FDIC 2023, packed house in a big area, standing room only to hear you specifically talk about pump operations. So let's run through what you were really doing, what you were talking about, and we'll get even deeper with that. So go ahead.
Yeah. So I think I look at it a little bit differently, a little deeper, but I'll look at the overall roles and responsibilities of a pump operator. I think, starting out in my fire service career, I faced the fact that, not many people, I can't vouch for you, but not many people get into the fire service with the intention of becoming an officer or with the intention of being in a senior staff or even being a pump operator. Everybody gets into the service to be a firefighter. And then when they get there, they realize that there are other options for them and even more challenges. And as they embrace those challenges, they see that, the pump operator is not necessarily just a stepping stone to an officer rank. Believe it or not, there's a lot of individuals in the fire service that actually seek that position as a career goal, is to become an engineer or chauffeur or pump operator, whatever you may refer to it as. But one thing that I noticed early on was we have a healthy dose of officer development. We have a healthy dose of recruit academies and, basic tactics and strategy to offer the fire service in a whole. You go to conferences, you got FDIC and many other professional development opportunities, but there's not really a healthy dose of good information, street level tactics, strategies, best practices offered for pump operators. And I think probably the biggest reason is that it's overall viewed as just a stepping stone to an officer rank or a stepping stone to a higher rank above firefighter. So when I noticed that, when I was promoted into the engineer rank, back with the horse and buggies, right? When I was promoted back into the engineer rank, I got a lot of in-house training that I was able to appreciate. A lot of, hey, this may happen to you, so you need to be prepared for this. A lot of troubleshooting skills, a lot of know-how, and most of that was not offered in a certification, a driver operator certification or whatever. But when I noticed that, I was like, I want there to be more information for those people out there that are like me that do want to make a career out of that. Now, I know since then I've promoted up and I'm now the chief of training for the city of Burlington Fire Department. But I'm in a position now where I can make those changes and really make sure that everybody here is offered what they need to be successful, especially our pump operators. But looking back to the overall roles and responsibilities of it, being a pump operator is not just standing at a pump panel. I like to look at it as all of the preparation leading up to that point. Knowing your routes and knowing your streets and particular situations to where you may not lead out on the engine. A truck may need to be leading out because of the situation dictated scenarios. But understanding what role you play when it comes to time to victims, or what role you play when it comes to time to extinguishment. The pump operator is kind of I like to say, the unsung hero of the incident. They fail at the pump operation role, the entire incident suffers from that. So I kind of break down an incident into three categories. You got the command post and a lot of the strategy being handled there, and then the tactics being handled, when it comes to extinguishment, ventilation, rescue, search, and then you got the pump operator. And we can make decisions on the fire ground, and we can extinguish fire. We can make our way to victims. But if that pump operator fails or is not effective at their job, it affects every other aspect of the incident.
And you make a great point. And that goes back to my concept of, do we have people just pulling levers, or do we have people that are truly proficient at the job of being a true pump operator? Because, one of the things, and I've noticed that we've dumbed this down. I even see the pictures now of on the pump panel where they put what you're supposed to pump it at. Well, what if you change the nozzle? Well, we're permanently set up that way. Well, what happens when there's a change? That's part of where I came through in being a pump operator. I remember that we were taught how to do calculations with hydraulics. Mm-hmm. And it wasn't none of this. You made these cheat sheet charts. It wasn't none of this stuff. You could have that stuff. But when we went through to be successful and to pass being a pump operator, we had to be able to do that mathematical equation in our head and be very darn close to it. Now, I've heard people say you turn it up to the feet come off the ground, back it up 2 turns. I felt like that's been the case a couple of times with some of the people running the pumps for us. It's like, okay, you're killing me here. Yeah. But you're right. However, we set the fire ground up. That first 2 minutes is how the next 2 or better hours are going to go. And there's so much more, like you said, to being a pump operator, being an engineer of that apparatus. And I think about that. And one of the things I think about that comes to mind was a gentleman that drove for me, and when I was in Chapel Hill, his name was Dennis Bailey, and he drove me on a ladder truck. Well, Dennis Bailey prided himself in being the engineer of that ladder truck, to the point he studied the owner's manual. Mm-hmm. He could tell you the torque pressure on the bolts underneath the turntable. He could tell you everything about how the levers worked inside and behind that pump panel. He could tell you how much friction loss you had, what some of your challenges were if you went into the rear port versus the side port, and if you were direct pumping versus pumping off the truck, how you could do a lot of things. Same thing that I had, with some folks that drove me on the engine, David Woody being one of them. They knew how to do the calculations. Claude Neville was another one. He used to tell me they kept him around to tell us where the toilet paper was. He'd been there for so long. But he could tell you where every hydrant was. He could tell you where every connection was on the university campus. He could tell you where the alarm panels were. And that's something that's critical is the chauffeur, is you're trying to get somebody from point A to point B, positioning that apparatus correctly, whether you're first due, second due, third due, whatever you are, and whatever role you're going to have. And then when you get to the scene, it's not just, okay, I'm going to stand here and pump this truck. There's a lot more that goes into that. There's ladders that are sometimes coming off these trucks, equipment, getting your connections to a water supply, all these other things that you have to do that goes into it. So let's break this down into a couple of sections. The first thing I heard you talk about was knowing about driving, your routes, your district, the positioning of when you come out of the station, if the engine needs to go first, if the ladder needs to go first, do they need to go in the same directions? Let's talk about that for a little bit.
Yeah, so I mean, I think it's very important, and a lot of that is predetermined. Okay, for an example, in the city of Burlington, we know we have a couple of overpasses where the train it's a train overpass, but our platform will not clear that overpass, so that platform has to take a different route. Well, understanding that we may not all be in a line strategically as we pull up on the incident, we may be coming in from two different locations, and if that's the case, do I need to think about as an engine operator or chauffeur or whatever? Do I need to be thinking about where is my water supply? If it's on the opposite side of the road, then do I need to let the truck come in from that opposite direction to get behind me before I shut the road down with a 5-inch supply line to a hydrant? So being strategic and timely, and just knowing that where your train tracks are, we try not to cross train tracks in emergency traffic. We have predetermined routes around emergency traffic or around those train tracks in emergency traffic. As long as it's within a timely fashion that we can still get to the incident. We don't want to commit the way our train tracks are. We don't want to commit to crossing a train track and then the cross arms drop there, and then we're having to regroup and so we have predetermined routes for that or around those. Another thing is FDC locations. That's big. Collapse zones, downtown districts where we have, what we consider high rise. Where are we positioning apparatus, in those particular locations? Obviously we have multiple apparatus coming from multiple stations, and we like to let each other know where we are, because in some cases we might converge on one another. So, we know where those hot intersections are to where we need to be paying attention to that. So a lot of pre-planning goes into your driver operator training, and it's very important to be aware of all of that stuff. One of the biggest things that I was made aware of is knowing your routes, because I look at, you look at a firefighter, a captain, a engine boss, whoever that is making that decision to make entry into the front of a house because that's the quickest way to a potential victim. Well, that's relates right back to the pump operator or the driver operator. You need to know routes to main thoroughfares in your districts, because that's your quickest way to the victim. So, thinking about it like that, it really brings a lot of importance to it. One of the biggest pivotal moments when it came to my advocacy for the driver operator position was a conversation that I actually had on the phone with Chief Bobby Halton. That was a couple of years back. The phone conversation was intended to be maybe 5 or 10 minutes. Hey, I need to talk to you about this. And about an hour and 15 minutes later, we got off of the phone. And all we talked about was the little things that are not thought of when it comes to the importance of the driver operator. And that being one of them. That is your time to victims and the crew's time to victims. That's where it all starts, is in that pump operator position.
And that's a big deal. And we don't think about that, but I know I've had drivers, and do you know where you're going? Yeah, and they go out of the station and they make a right and should have made a left. It's like, where are you going? That delays you, and that does have an impact on fire ground operations. It has an impact on the survivability of victims, those type of things. But let's break this down just a little farther. We were talking about when they're driving, when they're getting there. Most folks don't take into the account the responsibility that you have as a person that is chauffeuring that vehicle around. When you're going down the road, you're basically, in today's environment, you're chauffeuring about a $500,000 to an $850,000 piece of equipment. And then all the people that you're passing on the roadway, you have a responsibility for their safety. You have a responsibility for the safety of the people that are in your apparatus. You have a responsibility for the safety of the people that are in the buildings or walking down the sidewalks, or wherever you're at. That is a big deal. Most people don't think about that. Mm-hmm. And then they don't think about the responsibility they have for the billions of dollars of property that exist within their jurisdictions, that they have a responsibility too for the protection their inefficiency in, being able to chauffeur the vehicle, their inability in being able to do pump operations or FDC connections or knowing where hydrant locations are or positioning of that has an impact on the economic component and the quality of life of that community as a whole. They don't think of it that way. It's a bigger overarching picture. And that's where I tell folks, especially when we're trying to train them, or especially when we're training company officers about their roles and how they've got to train their people, is you got to have a window to the wider world approach. And I know you talk a lot about that in your class. So yes. let's get into that a little bit.
Well, you actually reminded me of a couple of things that that I need to actually add into some of the teaching that I do with pump operations. But, one of the biggest things that I think is not thought about enough is the legalities, of being that being that driver operator. If you have an accident, operating that apparatus, outside of the safety responsibility that you have of the public and the crew that's on the truck, two questions are going to be asked to you in court. Did you use due regard to the safety of the public, and did you use all of your audible and visible warning devices? And that's one of the things that concerns me a lot is, see an emergency apparatus not using all of their lights, or maybe not using their siren at 3 o'clock in the morning because they don't want to wake the neighborhood up. But at the end of the day, if you have an accident, a lawyer's going to have a field day in court with that. So the legalities, understanding your general statutes for your states that you live in, understanding what exemptions you may have while operating an emergency vehicle, those things are very, very important. And so the legalities of it are very important to be aware of, and especially when it comes to operating that apparatus, and don't need to be put to the side when it comes to your training and awareness. You mentioned the responsibility that you have for the safety of the public, but, I like to break it down when it comes to the overall responsibility. It's broken down into two categories when you look at the incident versus emergency versus non-emergency. On an emergency incident, obviously, your number one priority is the safety of that nozzle crew. You want to make sure that they have the effective pressure to be effective with what they're doing, effective water to be effective with what they're doing, but protect that nozzle person. Not emergency. Your number one responsibility is the safe arrival and departure of that crew that's on that truck. And that responsibility is also extended to their families. That's something else that needs to be remembered. They're just getting a ride to the incident. You are the one giving them that ride. You are responsible for that $500,000 to $800,000 apparatus, but you're also responsible for that, well over $100,000 of equipment that's on it. Now, with that being said, it's very appropriate to mention that who better to know that equipment on that truck than the engineer of that truck? What I mean by that is you're the technical specialist of all of that equipment on that apparatus. You check it off every day. You know what it's supposed to do. What is, I was talking to Chief Lasky a while back, and I had this very elementary saying of, in order to know something's wrong, you got to know what right looks like.
You're right. That's a perfect example. You don't know it's wrong because you don't know what right is. You don't have that concept of what's reality.
Right. So, when it comes to the equipment on the truck, how do you know if something's broken or missing a bolt or, not where it's supposed to be when you don't know what it's supposed to be like in normal operation? So you're the technical specialist of that equipment. Somebody hands it back to you clean to go back on the apparatus. You're going to run that one little quick check on it just to make sure that it's back in a useful state of readiness. I used to carry a little whiteboard, one of the little dry erase whiteboards on the truck. And, if firefighter Smith comes by and takes a pipe pole off my apparatus, I would write it down, just to make sure it's my own little personal accountability for my equipment on my apparatus. And at the end of the incident, I'd check, hey, if I'm missing my 10-foot pipe pole, firefighter Smith took it. Hey, firefighter Smith, where's my pipe pole? We're going to open a piston intake valve, wash it off real quick, dry it, put it back on the truck, when we have time to do all of that. But, I would go as far as saying if a firefighter came to you as an engineer on that apparatus and says, hey, what's the cutting pressure on our Hurst cutters? You should be able to answer that question. You are the technical specialist of that equipment on that apparatus. Is that a lot of responsibility? Absolutely. Is it a lot of information to retain? Absolutely. But it's just pride in your position and ownership into that position. I want to know how many, T25 bits I have in my toolbox on my apparatus. I mean, it's just the little things like that. Hose nozzle packages, that's important. I mean, it's 1 3/4 or 1.88 inch hose all over the fire service right now that's being pumped and packed on a truck as if it were 1 3/4. Fire departments don't know sometimes what they have in their fleet that is directly impacted by friction loss and pump pressures. And so knowing, what size hose you have on the truck, I know what you bought, what you think you bought, but do you know what you have? Being aware of all that.
That's another big thing. And I guarantee you talk about that in the class. Is the hose mixed to where you're having pressures from one side to the other side or changes or whatever it may be? That's a big deal.
Oh yeah.
If you go from 1.5 inches to 1 3/4, there's a friction loss difference, or you're not flowing the water that you think you're flowing, and that's another component that most people don't think about.
Well, I asked one particular individual, how did they purchase their fire hose, and they said, hey, we, no matter whether it's Mercedes, Snap Tight, Key, that none of that matters to me. It's preference to you and your resources, right? But the individual said, well, we buy what we get the best deal on, right? So that tells me right there that they're not into like testing for their friction loss and testing equipment. And you mentioned earlier about pump charts. I'll get to that here in just a second. But, one of the things that concerns me a little bit is we buy something, but we don't know the full capabilities of it, or we haven't tested it, so we don't know what it will do. We have found 1.88 inch hose mixed in with 1 3/4 true 1.75 inch hose, and there is a difference. And can you pump it at an average pressure and get away with it? Yeah, you can. But I mean, if you are not concerned about the details, and I actually upset a few people when I said this before, but I'm unapologetic about it because we don't get to pick and choose what parts of the fire ground that we're professional at. Okay. It's all in or all out. Those customers that we respond to want everything that we can give them. And if we're not firing on all cylinders and we're not precise in using that precision on every single aspect of that fire ground, then we're failing them. Okay. Now, what I'm about to say, again, upset a few people, but if you're not concerned about your pump pressures and you're not concerned about maximizing your capabilities of that pump panel, then that's the same type of person that is not concerned about searching that corner in that AB corner when they walk in that house or when they make entry into that house. We do not get to pick and choose what aspects of the fire ground that we're professional and precise with. And that's one of the positions that's easily, I guess, overlooked or gotten away with because, first of all, you're by yourself. You don't have people to bounce ideas off of. I even talked to somebody I mentioned in my class, I mentioned in all my classes that, I asked the question, how do you measure your success as a pump operator? On the fire ground, how do you measure your success? The firefighters and the captains, the engine bosses, the interior crews, the search crews, they measure their success off of extinguishment and rescue of victims. And the commanding officers in the command post, they measure their success off of successful tactics and oversight of an incident. How do the pump operators judge their success? How do you know if you did a good job? And my reply to them is when I ask that question, not rhetorical, I do expect an answer. You did a good job as a pump operator when nobody said a word to you at the end of the incident.
That is exactly correct. They're not out there beating on you or saying, hey, you were killing me inside, or, why didn't I have this, or why wasn't the equipment at the door, or any of that stuff. When all that's done, generally it's crickets for the pump operator.
Yeah. And, the precision that I mentioned it goes back to in any trade show that you go to, FDIC, whether it be Firehouse, whatever, any trade show that you go to, you see the advertisement, even in, even in your tactics that you learn in conferences. It's important. GPMs matter. They do matter. So when we talk about, for an example, a 7/8 inch tip and 160 gallons a minute, we talk about the fact that a 7/8 inch tip will give you 160 gallons a minute, but we don't finish the statement. It will if the pump operator is doing their job correctly.
Amen.
So we don't finish the statement. We see what's written on pump charts and we see what's advertised and we see the effects of 160 gallons a minute, but we don't finish the statement. And are we pumping it correctly? How do we know? Do we have 1.8 Do we have 2 inch? Do we have Super 2 from Mercedes? Whatever we may have we tested it? And that goes back to your pump charts. And I don't want to get on a rabbit trail, but I'm an advocate for pump charts. I'm an advocate for testing for your friction loss and not necessarily relying on industry standard. The problem with the numbers that me and you came up on back in the day is, for an example, the coefficient for 1 3/4 hose being 15.5. It might have been years ago, but it's not now. Coefficient, because of the manufacturing processes, is pretty much non-existent. It's obsolete in your process of determining pump pressures. Years ago, you stick your finger inside of a fire hose, you could feel texture. Now, most every fire hose on the market is like PVC pipe on the inside, right? So how do we detail that friction loss to determine our pump pressures? We have to gauge it out and test it. Every one of them is different. Every manufacturer is different. Test your hose. Look at kink factor. Look at weight of your hose. It's not just friction loss. There's so many other aspects of fire hose that make a difference. What are your effective GPMs in a 2 inch versus an 1.5 inch or 2.5 versus 1.5 inch? Testing that. But going back to your original statement of how those are sometimes considered cheat sheets, it is vital for your pump operators to not only know what that friction loss is, but to know where it came from and how it was derived.
Okay, so say that a little louder for the folks in the back of the room, okay? Those folks way back there, I want them to hear that.
Do not rely on the pump chart to be a cheat sheet. That's one of the things that I have an issue with, and I guess I'm a little old school, but I have an issue with the new technology that we have nowadays, especially in regard to a pump operator with the pressure governors and the presets, especially the presets. But, the SAM system, I love that stuff. It's all great. But what I see a lot of people do is use that to take the place of the thinking process, especially presets. Don't let that new technology take away the concept of thinking and working through problems on the fire ground. Don't let something do your job for you, because the pump panel is going to do what you tell it to do, right or wrong, but it's not going to tell you that it's wrong. You have to be able to determine that. So, when it comes to pump charts, I'm all for that. My advice is to test everything that you have, every nozzle that you have on every hose that you have. Take that data, friction loss per 100 feet. Okay, that way it's per 100 feet. If you have a 150-foot lay, a 250-foot lay, a 400-foot lay, as long as you know what it is per 100 feet, you'll be able to work your way out. If it's only 50 feet, cut that number in half. If it's 200 feet, double that number. Add your nozzle pressure, figure out whatever elevation loss you may have, appliance loss that you may have, and put it together and pump it. It's that simple, but you have to know where those numbers come from. So when it comes to testing for friction loss or testing for appliance loss or whatever you're trying to test in your hose nozzle packages, the pump operators need to be involved in that testing process. That does not need to be done by a chief of training or a captain in the training division and then just handed to somebody. Your pump operators need to be involved in that testing process so they can know where that data came from and understand it better.
And let's take that a little bit further. You were talking about in your jurisdiction, I know I have those, but most people will have areas that have more than one floor. It's not all single level. For some of us, we get into the 30, 40-story buildings. For others, it may be 2 or 3 stories. But it's important to know when you've got that hose going up, what the friction loss really is once it gets to the nozzle. Again, you were talking about, let's do the actual equations. Let's go out and flow it. Let's put the meters on there. Let's test and verify what we're doing. It's the same thing that you do in high-rise operations. Is you go out, and I know that they go and by code they test these to make sure they're flowing X amount at the top floor, and they have to get so many gallons. The pumps have to do this. I understand all that, but what happens when we hook to that and we're pumping it? We're helping supplement that system. And what happens when we're engaged in fire suppression operations on the 25th floor or the 20th floor, or the 10th floor, whatever it may be? You've got to know exactly what that hose is doing, what its performance is. And by being involved in the testing, being engaged in that, actually grows the knowledge and the connection between the people on the nozzle and the person at the pump panel. And you brought this out. It's, these preset settings are great until all of a sudden it's not a 200-foot line. You got to go to a 300-foot line or a 400-foot line. And we know that happens. We know that in certain situations you're dropping leader lines. We had a good single family residential structure, large square footage, 2 stories, heavy fire volumes, and it was requiring a lot of water flow. Well, that pump operator was getting a real test because we had 2 3-inch lines running to the rear of the building, flowing master streams, those blitz fire style guns. We had 1 3/4 inches on the ground. I mean, you just can't start just playing around with it and say, oh, I'm going to give you this, or the preset setting. That's not how it works, because all of a sudden it's not a standard hose lay. We've added hose to that. We've, stretched farther than what is normal. So you have to be able to figure that in your head. And one of the things that I always get people, and I'll do this, I'll walk into a group of people, especially if it's a class or a pumps class or people that are talking, I'll go, how far can you relay pump a 2.5-inch hose flowing 1,000 gallons of water? Well, we know what the formulas say. It's 2 cubed squared times the length. That gives you your friction loss. But there's also something that comes into play is when you start flowing water and you have to start running your pressures higher. It's like when you're drafting, you can only get so much out of that truck. So a good example is you take 1,000 divided by 100 is 10. 10 squared is 100. Well, automatically, that if you multiply that by 2, that's 200. That's 200 PSI for 100 foot of hose. When we get to 200 PSI on a truck pumping it, you're only going to be able to flow so much capacity. You're stretching that pump tight. So automatically, if it's a 1,500 GPM pump and 150 gives you that 1,500 GPMs, when you're drafting, you get to 200, you just drop that ability of that pumper down to about 1,000 GPM pumper.
That's exactly
that. And that's just rough data, scientific evidence, quote unquote. Now, depending on how old that 2.5-inch hose is versus the new, the make, the model, the brand, the couplings, the whole 9 yards is the friction loss there. But basically, you can go 100 foot with 1 2.5. That's the reason in the old days you were laying the dual 2.5s down the streets. And then they said, oh, if we go to bigger hose, 3-inch hose or the 4-inch hose or the 5-inch hose, you can flow more. And they're exactly correct because of the friction loss and the changes. So again, you have to take all that into consideration that a lot of folks don't. So talk a little bit about, let's go to FDIC. What a great show that was. What a great venue, about 38,000 plus people that were there. One of the biggest crowds I've seen in a long time. I had a little bit more time to see the crowd this year, so that was a lot better. My schedule had dropped off a little bit, some of the activities I typically have at FDIC, but a great crowd. I saw classroom after classroom packed, which was phenomenal. That's exactly what we want to see. I saw people in the hallways that were, intermingling, and the education that was going on there, and the vicarious learning and the sharing of experiences. The folks in the podcast booth where they were video podcasting at the main corridor there. And like I said in the very beginning when I introduced you, your room was packed. So why do you think people came to hear about pump operations? What do you think is the attraction all of a sudden to something that is about the most unsexy component of the fire service? And we're not talking about, vent enter search, and we're not talking about rapid intervention, and we're not talking about, stretching lines. We are, but we're not. What made people want to come to that? What do you think made people want to come to that specific program of yours?
I think first of all, and I'm obviously a supporter of fire engineering, but I don't mean to sound so biased here, but FDIC, is known for being there for every firefighter from every rank to every division, and being able to offer a healthy dose of everything. What surprised me, well, first of all, when my class was first accepted to FDIC, back last year, when I first brought the pump stuff, I was very surprised at the attendance in the class. It was the first time a class had ever been offered, so I was kind of sketchy on, I wondered, because it's like nobody heard about it last year and wants to come this year. So, but I had a lot of attendance last year, and then this past year it was almost double. And the feedback that I was getting at the end of the class, when quite a few people approached me at the end of the class and said thank you, and it's like, okay, thank you for the content. What exactly are you thanking me for? Thank you for bringing pump ops or some type of pump ops class to FDIC. There's a healthy dose of everything, but I really needed to hear this. And this guy ended up being a training chief at a smaller department somewhere out in the Midwest. And, most everybody by raise of hands in my class was already an existing pump operator, just looking to grab that one little puzzle piece, that they were missing out of their puzzle. Maybe they did not get that from another class. Fortunately, there's been other pump operation classes offered at FDIC, one or two this year, and by awesome instructors. Hopefully those folks that, sat through my class and maybe still didn't get their puzzle completed was able to go to one of those other individuals' classes and hear it from a different perspective. But I do think that pump operations completed almost like it completed the circuit at FDIC, right? Having at least 4 or 5 options there for those individuals to come to, because again, there are many firefighters in the history in throughout the United States right now that look at that as a destination position. And when you look at it as a destination position, you go out and seek further information on it. And, where better than to try your shot at getting that information than FDIC. Had a lot of existing pump operators that had been pump operators for anywhere from 10 to 15 years come up asking, can you give me some advice on relay pumping? How do you set your apparatus up? What size hose do you use? And, I want to make sure that everybody, I'm doing my part so that everybody that comes to that conference, no matter what you're looking for, is able to pick up puzzle pieces from any aspect of the service, right? But I got a lot of good feedback from a lot of people saying, hey, man, I never really thought about it like the way you explained it. I even now realize that I do have more responsibility than I thought I had. I thought I was just there to make water come out of the end of a hose line so the nozzle crew could go to work, but it really gave some of the class attendees a different sense of pride. Like, wait a minute, I am proud of what I'm doing as a pump operator. I do matter. and it fires them up. And when that fires them up, they want to go out and get even more that they didn't get in my class. It reignites that spark in them to where they go home and they research and they study. And, I've got quite a few emails. I spent that entire Monday when I got back from FDIC answering emails from some of the attendees in the class. Frank Ritchie picks on me a lot about, how do you get that many people to come to a class that many people just don't seem, or on a topic that many people don't seem to be interested in. And I think it starts out with the awareness of it and the bringing to light the true responsibility that you have on that incident and leading up to that incident. But, again, I can't thank the attendees enough for showing up for my class like that. I was not expecting that. And, I'm excited about the possibility of next year of being able to, I've already made changes to my presentation of things that I got fired up about in the class that some of the students want me to add. So, I'm excited about throwing that out there next year. But, like you said, FDIC was a huge success this year. A lot of behind the scenes work that went on. I didn't get a chance to do something. I want to make a point to do it now. I did not get a chance to thank a particular group of people in my class because it was right toward the end of when my class was supposed to start. I had a little AV issue. The AV team at FDIC and all of the volunteers, the recognition for those folks, oh my God, they're so awesome. And the help that they were able to offer me so that my class was able to, roll on. I had just a little minor AV issue, but those folks are so professional, represented, Clarion Events, Fire Engineering, FDIC, so awesome. I just wanted to make a point. I don't know how many of them may catch just a little glimpse of this, but I want to make a point to recognize those folks, all of those volunteers and the AV team behind the scenes at FDIC. True group of professionals there.
Oh, they definitely are, and they do a great job. And again, the whole staff of FDIC,
absolutely,
just phenomenal event. Well, Paul, I certainly appreciate you coming on the show to talk a little bit about pump ops, and hopefully this fires our folks up and they want to get to looking at more into pump operations and knowing more about the importance of it. If they need more information, how do they get in contact with you?
My mobile number, my email address, I can be reached by email at P Watlington. That's PWATLINGTON at burlingtonnc.gov, Gov. My mobile number is open for anybody to. I give that out in my classes. It's on my instructor profile. So I have absolutely no problem giving it out here, 336-504-5078. I want to be a resource to you. I'm just a messenger here. I'm not making this stuff up. So if there's anything that I could be, or any way that I could be of assistance to anyone, especially in this topic, feel free to reach out to me. I'll come to you. You can come to me. We can email. We can share information. Anything that I could do to make pump operations great again, Doug.
Make pump operations great again. I'm with you. Well, Paul, thank you for being on. Again, thank Fire Engineering for hosting Fire and Training. I'm your host, Douglas Cline. Of course, I'd be remiss if I didn't say that this show is dedicated to the men and women who are in the streets 24 hours a day, 7 days a week, 365 days a year. Career, volunteer, doesn't matter. We're out there being professional, taking care of business, and we're dedicated to everyone going home. So thank you for tuning in. We'll catch you on another edition of Fire and Training.